All right, this is a bit of an apology here because I feel like I really bashed wave theory and I want to apologize, but I also I think it's so funny because I do this every time. Um, uh, you know, uh, I want to apologize, but I was also not wrong. As I said, we can eat our cake and have it too. Photons are not waves, they are particles, but their motion creates waves like that of a boat through water. There are material waves that I will consider as sound waves. This is our level, matter. There are electromagnetic waves, which are below us, and I believe is more based in dark energy than anything. And then there are gravity waves, which are above us and are based more in dark matter than in physical matter, right? And so, these levels being of energy density with lower levels being, these levels being of energy density with lower levels being higher energy and higher levels being lower energy, just as smaller wavelengths are higher energy and larger wavelengths are lower energy. Okay. Basically what I'm saying here is that, I think I've said it before, but I've definitely said some of this before, but electromagnetic waves are not their own. Like, the electromagnetic force is not a fundamental force. It's not, like, it's an emergent behavior from a fundamental force. Well, fundamental force that we call gravity. Gravity is the cause of electromagnetic radiation at the core. And the behaviors that we see, these charges and stuff, is really just our way of understanding and communicating energy differences and, in a sense, basically just gravity at an extremely small scale from our perspective. But if you picture yourself as the size of these atomic structures, right, these subatomic particles, they are quite large or small compared to one another, right? And so what we see as, oh, there's no gravity there because it's such a tiny particle, that's like saying there's no gravity, like we don't experience gravity compared to the sun or like the earth because we're so tiny, right? That doesn't make sense. It doesn't make sense that because, just because, another star may look at us and go, you're barely even affected by it. You're not even affected by gravity. You're just affected by, you're positively attracted to the earth, but it doesn't, like, to us, that wouldn't make any sense. Like, you're probably thinking, like, what the heck is this guy talking about? That's so stupid. But that's what I'm saying. It is so stupid. Why do we think that, electrons that are, like, basically like a tiny little baseball flying around in empty space where there's a nucleus, right? And the nucleus is much larger in comparison to an electron, and they just kind of fly around, and we don't know where they're gonna be. They just kind of are anywhere and everywhere all at once. And there's a theory that one electron is every electron in the universe, and I don't know what they're smoking with that one. Gravity creates electromagnetic radiation because, and a photon is just a particle. And so a particle is flying through space. And I've talked about this before with basically infinity and stuff. So a photon is flying through space. And just as there are photons and atoms everywhere around us, to an electron, there are particles all around it. To us, there's nothing there. And we observe just this vacuum energy kind of fluctuating and whatever. But to an electron, there is a sea of particles around it that's akin to basically air or something else. Maybe something denser than that. I don't know. Okay? Like, I can't see this. I don't know. But theoretically speaking, electrons basically in a sea of particles. And so it's flying through this sea of particles, and as it flies through this sea of particles, right, it's getting pulled, just as the Earth is in a gravitational pull with the sun, right? And the sun is flying through space, right? The sun is flying through space, and the Earth is continuing to fly around the sun as the sun flies around in space, right? So because the Earth is being basically drug along by the sun, you could see, you could almost like see Earth is basically just being like holding on by a rope and getting tugged along, right? And so, basically, an electron, or not an electron, but a photon is flying through space, and in its wake is, an area that has less particles, because as the sun flies through space, right, any random space debris, any asteroids, anything like that, is getting kind of collected inside its gravitational field and being pulled along for the ride, right? And so in its wake, there is less material randomly scattered about than there is, in front of it. And so because of that, it continues to move along. And as it goes, there's less material here, but there's more material, as you go outside of its wake. So there's less material in its track, and then you go outside of its track, and there's more material again. So any particles that are floating around there are going to be like, all these particles also have particles, right? And so there's no particles that are kind of gravitationally pulling on them inside the wake of this photon. And so what happens is that they go, as I talked about with like magnetic fields, is there's no energy here. Let's go, it's not energetically favorable to go where there's less energy. So let's move towards where there's more energy. So they kind of get pulled away from the wake, right? But then they bunch up against where there is more particles, and eventually they reach a point where they're like, there's too many people here, it's getting crowded, right? So at that point, now the direction they came is more energetically favorable because the density increased, right? So now the density increased here, and so it's less energetically favorable to stay packed together, and so they move apart. But the thing is that now these ones that bunched up also want to move away as well. So where do they go? They keep moving out, and then they bunch up again, and then they bounce, and you get this kind of wave pattern forming in these particles, but these particles have nothing to do with the photon, right? The photon is not the wave. The photon created a wave by just being there, by just doing what it's doing, right? Just as when you're in a boat, right? You're driving along and like you look back, right? You got this kind of V, kind of a wave rolling out from the back of your boat as you move through the water, because you had to move water out of the way, right? Like as your boat moves through, there is less water where your boat was than where, the water is. And so the water moved out, right? Because it had to make room for you to fly through on your boat. But then once your boat is gone, well, then it collapses back in, right? But that wave doesn't just stop. It keeps going, because that imbalance now pushes on everything else and pushes everything else, and it keeps going, and eventually it dissipates. It slowly, dissipates out, and the movements are less drastic over time because the amount that they get compressed is less and less, and eventually over time that energy is dissipated out, and so you no longer have this magnetic field. But again, those waves, like the waves of the electromagnetic wave, are just particles, are just particles, right? There's no abstract concept of a wave there, right? The way that quantum mechanics describes particles as this random quantum fluctuation wave in the magnetic field or the electromagnetic field or the electro field, or I don't know exactly. But basically all the subatomic fundamental particles are just random quantum fluctuations in these fields, and they're all waves by definition. And I don't think that's right. I don't think that they are at their core fundamental level a random fluctuation in a field. I think they are a physical particle that is causing fluctuations in a field by their interactions. And these interactions, this electromagnetic radiation, these waves emerge from gravitational forces at beyond the subatomic level. It's not that we're going subatomic, we're going subatomic, and maybe even subatomic. Like, it's not like, it's extremely, these particles we're talking about are uncomprehendibly small to us. But we see behaviors that mirror it in everything. We see it in water, we see it in wind, we see it in solid materials with vibrations and sound waves, and it's everywhere. This behavior is everywhere. But we observe them as, sound waves have nothing to do with electromagnetic radiation. And I don't think that that is a logical conclusion. I think that seeing similar behaviors in different, conceptually different, situations should be something we put more investigation towards. And what I was getting at with my initial listing is that we see waves everywhere, and so we think, for some reason we think that waves must be the fundamental level of everything. But everywhere we observe waves happening, there is a cause for the wave. It's not a random fluctuation that creates this wave on levels that we observe. So why do we think that it's a random fluctuation on a level we can't, right? Why do we think that that must be the fundamental level? Because every wave that we observe everywhere, right, except for at the subatomic, is made up of a smaller particle, right? A wave of water is not a wave, my bread is done, is not a wave by definition, right? It's not a wave until something acts on it and causes the material to form a wave. It doesn't just form a wave on its own. If you leave water to just do its own thing, it's never gonna just randomly start rippling. It doesn't do that. Something has to act on it for it to ripple. So why do we think the fundamental building blocks of our universe are random ripples? I don't understand. I don't understand. But yeah, I feel like I might have gotten a little off topic from where I started, but I guess that's par for the course these days. So, peace out.